Hi, this is Savita Pruthi, your maths tutor, and I am going to teach you exemplar problems for grade 9, right? Exemplar problems are very important in the application of the concepts. We learn the concepts from the books, but how do we apply it in daily life? Exemplar problems help a lot in learning that. All right, so we are going to start with exercise 1. Here we go. Yes. So the first question says, every rational number is a natural number or an integer or a real number or a whole number. So first of all, you should know these various terms. What is a whole number, integer, real number and a natural number. So I'll try to explain this by a Venn diagram. This shows a universal set of real numbers. So real numbers, we know all the numbers, whether it's rational numbers or irrational numbers, right? I think you all must be knowing what are irrational numbers. Irrational numbers are of the form root 3, root 5, or we can say that irrational numbers are non terminating, non repeating numbers whose decimal representation is non terminating, non repeating. They are irrational numbers. And rational numbers, which can be written as P by Q. These are the rational numbers, right? So real number consists of rational numbers and irrational numbers. Now, the outermost circle is the rational numbers. In rational number comes the integers. In integers comes the whole numbers. In whole number comes the natural numbers, right? So we can say rational numbers are real numbers, right? Because all rational numbers may not necessarily be integers, right? But all rational numbers are necessarily real numbers because rational numbers are a part of the real numbers, right? But all the rational numbers may not be integer, may not be whole number, may not be a natural number. So every rational number is a real number. So the answer is C, right? Now we go to the next question. Between two rational numbers, how many rational numbers are there? There is no rational number. There is exactly one rational number. There are infinitely many rational numbers and there are only rational numbers and no irrational numbers. I would say there are infinitely many rational numbers because there is no rational number. It's not true. For example, say we take 2 and 3. Number 2 and 3. And we can see between 2 and 3 there can be so many numbers which are rational numbers. It can be 2.1, it can be 2.2, or it can be 2.35, or between 2.2 to 2.35 also there can be so many numbers, 2.25, like that. So we see that there are infinitely many rational numbers between the two rational numbers. So the answer C is true for question number 2, right? Now, next one is decimal representation of a rational number cannot be terminating, non-terminating, non-terminating repeating, non-terminating, non-repeating. Now, decimal representation of a rational number can be terminating. For example, 3.4, it's a terminating decimal and it's a rational number. Non-terminating, it can be non-terminating, 0.333, and this is a rational number. Non-terminating, repeating, yeah, for the above example is non-terminating and repeating also. Non-terminating, non-repeating, that will not be a rational number because this is an irrational number. Right? So the decimal representation of a rational number can be terminating, non-terminating, non-terminating, repeating, but it cannot be non-terminating and non-repeating. So the answer D is correct. The product of any two irrational numbers is now Is it always an irrational number, a rational number, an integer, or sometimes rational, sometimes irrational? Now, this will be explained by an example. Suppose we have two irrational numbers, say 2 plus root 3 and 2 minus root 3. Both of these are irrational numbers. Now we will see. They are saying the product. So if we multiply this, so it will be, if you multiply, this will be done by using the identity a plus b times a minus b equals a square minus b square. So it is equal to 2 squared minus root 3 squared. So which is 4 minus 3, which is 1. So we see it's not an irrational number. So the first part is not correct, right? Now they are saying always irrational number. Now suppose we take the number root 3 and root 2. Both of these are irrational numbers, but if we multiply them, we get root 6, which is also an irrational number. So the second one is also not correct. It's not that always irrational. Always an integer. This is also not true. We can see here we are getting an irrational number. So this part is also not correct. Now it says sometimes rational, sometimes irrational. Yes, we are getting a rational number here and we are getting an irrational number here. So we can say sometimes rational, sometimes irrational. So that holds true, right? Now, going to question number 5, the decimal expansion of the number root 2 is a finite decimal 1.41421 non-terminating recurring or non-terminating non-recurring. It's not a finite decimal because it's an irrational number. So it will not be a terminating decimal. This is also not true, the next one, because it continues to go on beyond this also. It's non-terminating recurring also. It's not that because so the D part is true. So if we do it, the decimal representation of root 2 will be non-terminating, non-recurring. It will not repeat and it will not terminate also. Alright? Now the next one is which of these is irrational? So we can do this by simplifying them first. Now root 4 by 9 can be simplified to 2 by 3. Square root of 4 is 2, square root of 9 is 3. Now root 12 by root 3 is root 4, which is equal to 2, which is again a rational number. This is a rational number. Root 7 we cannot further simplify, and this is an irrational number. And root 81 is 9, which is a rational number. So the answer is C. So which of the following is irrational? Root 7 is irrational. Rest all are rational numbers. So these questions also make our concept about rational and irrational more clear, right? When we practice these questions, this concept is more clear into our minds, right? Now, which of the following is irrational? As I've told you, irrational numbers are non-terminating, non-repeating, right? So we'll see which of these is non-terminating and non-repeating. The first one is terminating. The second one is it's non-terminating, but it is repeating. C is also non-terminating, repeating. But D is non-terminating and non-repeating. So this is an irrational number. Correct? Now, next. Question 8 says we have to tell a rational number between root 2 and root 3. So, how we find a rational number between the two rational numbers is just add them and divide them by 2. So root 2 plus root 3 by 2 will give us a rational number exactly between root 2 and root 3. So the first option is correct for question number 8, right? Now going to question number 9, we have to tell the value, we have to write the number 1.999 repeating in the form P by Q. Means here we have to write non-terminating and non-repeating number in the form of a rational number, right? So how do we do that? So first of all, we'll put it equal to x, right? So let x equals to the given number. Now multiply this by 10. So we get 10x equals, now when we multiply this by 10, the decimal is shifted to the right by one digit, so it becomes 19.999. Because it goes to infinity, so it will be the after decimal it will be the same thing. From this we subtract x, which is 1.999 non-repeating, non-terminating. Now from this 10x you subtract x and we get 9x equals 18, right? And now x equals 18 by 9. Isn't it interesting that we are getting a non-terminating, repeating decimal that is equal to a whole number? Yes, that is very much true because 1.9999 to the infinity will be almost equal to 2. So the value of 1.9999 is equal to 2, right? Now we go to question number 10. Yes, it's very simple. 2 root 3 plus root 3. Now, root 3 suppose this is some variable. So what is 2x plus x? That is equal to 3x. So same way, 2 root 3 plus root 3 will be 3 root 3, right? 2 times root 3 plus 1 time root 3 is 3 times root. Now we go to question number 11, root 10 times root 15, that is equal to root 150. But we have to simplify root 150. Now we can write this number as a part which is a perfect square and which is the not a perfect square. We can write it as 25 into 6. Square root of 25 is 5. So we'll write it as 5 root 6. So the answer is 5 root 6. So what we have to do here basically, we multiply them in the roots and then we separate the perfect square part from the non-perfect square part and then we take square root of the perfect square part, right? Now question number 12 we do. They are saying what is the number obtained on rationalizing the denominator of 1 by root 7 minus 2? Right, so here for rationalizing such numbers, we have to multiply them by their conjugates. Now, what is the conjugate? Now, conjugate is the similar number but with the opposite sign, like 1 by root 7 minus 2. We have to rationalize. So, we'll multiply it by root 7 plus 2. We'll multiply and divide, right? So, this root 7 plus 2 is called the conjugate number of root 7 minus 2. So we'll multiply and divide so that there is no net change in the value of number. So when we multiply, we get root 7 plus 2 in the numerator and in the denominator, we get root 7 minus 2 times root 7 plus 2. So this is root 7 plus 2 by, if you simplify this, root 7 squared minus 2 squared. Now this is root 7 plus 2 in the numerator and here we get 7 minus 4 which is 3. So we can see the answer for this is root 7 plus 2 divided by 3 which is the option A, right? Okay. Now we go to question number 13. Yes, so here also we have to rationalize it. So as we know, we have to multiply this by the multiply and divide by its conjugate, which is root 9 plus root 8. Yes, so numerator is same because it's being multiplied by 1 only. And here, using a plus b into a minus b identity, we get root 9 squared minus root 8 squared. So 9 plus root 8 here, we get 9 minus 8, which is 1, right? So we get root 9 plus root 8. Now we see in the option there is no answer like this. That means we have to simplify this answer further. Now, what is root 9? This is 3. And what is root 8? Root 8 we can write as 4 times 2. As I have told you, we can simplify these numbers by breaking it up into a perfect square number and a non-perfect square number. So it is 3 plus 2 root 2, right? Now we see, yes, D is the option, correct? Now question number 14 says, after rationalizing the denominator of this given expression, we get the denominator as. So we have to just rationalize the denominator, which is 3 root 3 minus 2 root 2. So for rationalizing, we just multiply by its conjugate. So this is 3 root 3 whole squared minus 2 root 2 whole squared using the a square minus b square identity. It becomes, now if we square 3 root 3, it will be 9 times 3, 27 minus 4 times 2, which is 8. So 27 minus 8 is 19. So 19 is the answer here. Yes, now we go to question 15. So we have to simplify this. So first of all, root 32. So root 32 we can write as 16 times 2 root, and we know that square root of 16 is 4, so this becomes 4 root 2. Now root 48, that we can write as 16 into 3. So square root of 16 will be 4, and this is 4 root 3. Now root 8 we can write as 4 times 2. Square root of 4 is 2, so this is 2 root 2. And then root 12 we can write as 4 times 3 root, so which is 2 root 3. So we'll just plug in these values here. So root 32 is 4 root 2 plus root 48 is 4 root 3, and denominator is, in place of root 8 we'll write 2 root 2, in place of root 12 we'll write 2 root 3. So we can take 4 common from the numerator, we get root 2 plus 3 inside, and we take 2 common from the denominator and we get root 2 plus root 3 inside. Now this whole expression can be cancelled out, and 4 by 2 is 2. So the answer is 2 here, right? Now question 16. They have given us the value of root 2 and we have to evaluate square root of root 2 minus 1 by root 2 plus 1. So first of all, we have to rationalize the denominator here. So we have to multiply and divide this by root 2 plus minus 1 by root 2 minus 1, because we have to take conjugate of the denominator here. So everything inside the square root, here we get root 2 minus 1 times root 2 minus 1, which becomes the root 2 minus 1 whole squared, and the denominator is, again using the identity, a plus b times a minus b, which is equal to a squared minus b squared. This becomes equal to root 2 squared minus 1 squared. Now root 2 squared is 2 and 1 squared is 1. So denominator comes equal to 1 and the numerator remains the same, root 2 minus 1 whole squared. So the whole expression is square of root 2 minus 1, right? Now square root and square get cancelled and we get the answer root 2 minus 1. So the answer for question 16 is root 2 minus 1, right? So that is the answer for question 16. Yes, so we had got the answer for question 16, root 2 minus 1, right? And now we know that root 2 is 1.4142 and minus 1. So the answer will be C here, correct? Now we go to question 17. Yes. So this is fourth root of third root of 2 squared. So how do we do it? So fourth root means the power is 1/4. Third root means the power is 1/3. So we can write it as this is 2 to the power 2 whole power 1 by 3 and the whole power 1 by 4. Now if we simplify, so we get 2 to the power 2 times 1 by 3 times 1 by 4. Now 2 and 4 get cancelled, so we get the answer 2 to the power 1 by 6. So C is the option. C is the right answer. Now question 18. Again the same thing, root 3, root 4 means the powers are 1/3, 1/4. So we can write it as 2 to the power 1 by 3, then 2 to the power 1 by 4. Now 32 we can write as 2 to the power 5. So this becomes 2 to the power 5 times 1 by 12. Here also I'll explain it separately. 12th root of 32. 32 we can write as 2 to the power 5. So this can be written as 2 to the power 5 times 1 by 12, or we can write 2 to the power 5 by 12. So it becomes 2 to the power 1 by 3 times 2 to the power 1 by 4 times 2 to the power 5 by 12. Now using the laws of exponents, we add all of these powers. It becomes 2 to the power 1 by 3 plus 1 by 4 plus 1 5 by 12. And by taking the LCM, we get 4 by 12 plus 3 by 12 plus 5 by 12. And yes, we see that it comes out to be 12 by 12, which is 1. So it's 2 to the power 1, which is 2 only. So the answer is quite interesting. It's 2. We see the question statement seems quite complicated, but the answer is very simple. That is just 2. All right. Now going to question 19. Very simple. Again, fourth root means power is 1/4. So we have 81 to the power minus 2 and the whole power 1/4. And by using the laws of exponents like a to the power m whole power n, that is equal to a to the power mn. Power of power means we multiply the powers. So here also we multiply the powers. Minus 2 times 1 by 4, that gives you 81 to the power minus 1 by 2. Right? Now when it's a negative power, so we take it as a power of the reciprocal. This is 1 by 81 to the power 1 by 2. Half power means we are taking its square root, right? So square root of 1 by 81 will be 1 by 9. So the answer for 19th is 1 by 9. Right? I hope you understand what is the meaning of power 1 by 2. Power 1 by 2 means square root. Right? As we were doing here, you can see uh, third root, fourth root meant 1 by 3 power, 1 by 4 power. So similarly, 1 by 2 power means square root. So we can write it as 1 by 81 square root, which is 1 by 9. Right? So this is the answer for 19. Now we do question 20. So this is 256 to the power 0.16 times 256 to the power 0.09. Using the laws of exponents, a to the power m times a to the power n, which is equal to a to the power m plus n, we get 256 raised to power 0.16 plus 0.09. So which is equal to 0.25. So 256 raised to power 0.25. Now 256 we can write as powers of 2, or we can write as powers of 4. So 256 as a power of 2 is, it's 2 to the power 8, right? And 0.25 we can write as 1 by 4. Now 2 to the power 8 times 1 by 4 will be 2 to the power 2, which is 4, right? So A is the right option here, correct? Now question 21, which of the following is equal to x? Means we have to simplify this. It's very simple. Now, the option A. Now, many students will do this as x raised to power 12 by 7 minus 5 by 7, which is wrong because it's not division. They are subtracting this, right? And these are different terms. These are unlike terms we cannot subtract, correct? Don't mix it with the thing which shows that x raised to power 12 by 7 divided by x raised to power 5 by 7, that would be equal to x raised to power 7 by 7. So don't mix it with that, right? Many students will do this. 12 by 7 minus 5 by 7 equals 7 by 7 and this is equal to x. No, it's not correct. Be careful. So this is a catch. It's minus here, so power won't be subtracted here. Correct? Now we go to the next. So this is not simplified to x, so A is not the option. Now we go to part B. Let's see here. Root 12, so we will write it as x to the power 4 times 1 by 3 times 1 by 12. This is also not going to be simplified to x, so we leave it here. So yes, so square root of x cubed means it's x to the power 3 by 2 and the whole power 2 by 3. And we see this comes out to be 3 by 2 times 2 by 3, which is x raised to power 1 because 2 and 2, 3 and 3 are cancelled. So this is equal to x, right? So C seems to be the right option. We'll check D also. Yes, so when we multiply the same basis with different powers, powers are added. So 12 by 7 plus 7 by 12, it's not going to give us x raised to power 1. So this will not be the right answer. Answer is C. All right. Okay. So that's all for today, guys. If you liked my video, please like, subscribe, and share it. Hope you enjoyed it. Okay, bye bye. Have a great time.